Yeah, hello, this is Günther from Berlin, and today I would like to talk a little bit about CTDB, the clustered version of Samba. Recently, there have been some discussions on the Samba mailing lists how to get up CTDB working with a clustered file system from Oracle OCFS2. And there are different approaches how to do so, and because I mainly use OpenSUSE for development, and I have some experience with corosync and pacemaker, I was thinking about it, whether it could working or not, to get it up working with OpenSUSE. So I'm using a host system with OpenSUSE, and I've set up 2 virtual machines also running OpenSUSE. But the cluster stack composed with corosync and pacemaker is not really complete in the normal distribution of OpenSUSE, so I had to use some special high availability repos. Only one. It was because Nick Digimer on IRC said that you should use very recent versions of corosync and pacemaker, so life will be a lot easier. So you see the additional repository here. When I used it, I got the following versions of corosync and pacemaker. I also did a separate install. I'll talk about that probably later. It's a Linux cluster management console. It's a Java GUI. But as I said about that later. So first let us have a look. Here with terminal from on the host system, and here are my virtual machines I've set up. And as you can see, besides the usual partition setup I used in these virtual machines, I've set up an additional partition, dev SDB, about 10 gigabyte on both, same size on both virtual machines. And with Vmware Workstation you have to take some care, because this is a drive, a partition which you must share, be able to share between the 2 virtual machines. But I will not ask to talk about that here, how to do that. It's not so complicated, but take care to do it right. So I'm also using some shortcuts, because system control and journal control are very long words. So I use system control, and when I look here, status, the pacemaker service is not working. With recent releases, when you start the pacemaker service, the dependent corosync service is also started. So you need to only start pacemaker, and all other stuff will be started again. But still, so let us start the corosync service here. Sorry. The pacemaker service. We do so, and if you look again, the pacemaker service has been started. We can do it here too. So also here we see we have it running. So what does it mean? I already had set up some pacemaker stuff before, because when you want to have a OCFS clustered, you need a log manager to between the two, and also when you want to use OCFS with pacemaker, you need to use a special mcifs command, which you see here. You must specify the cluster stack, because it's not the default one when you install OCFS. And here PCMK is used, which is abbreviation for pacemaker. Also in that case, you need to set up a cluster name. And here you see I want to format, I have format dev.sdb. That was a 10 gigabyte partition. Let's have a look again at the status. And what you can see now, a distributed log manager, it's a resource agent for pacemaker, has been started. Yeah, the same has happened here. That's because I already did some configuration for pacemaker. Otherwise it would not happen. Pacemaker must know which resource agents you want to use. We can use the CRM shell to view the status of the current configuration. And what you can see here, I've only configured 2 nodes and 4 resources. So both nodes are online, 1 and 2, and also the clone. When you define a resource agent and want to run it, to have it run on both machines here, you have to use a clone of that resource agent. And also, besides the log manager, I also used a resource agent to set up a file system. And as you can see, they both have started on both clusters. And when we use mount here, we wanted to use dev.sdb as our clustered partition. And you see it has been mounted on share 01. You see the other options here, OCFS2 and tralala tralala, and here cluster stack PCMK is used. The same should be true, hold true here. When we mount it, we get the same mount here. So let us switch over to the share and have a look. There is also something stored there. Yeah, but the main question is, and if you have followed the discussions on the mailing list, is it really usable, what we have done so far? And long time ago, Andrew Tigel from the Samba team has written a interesting test. It's called ping pong. And what ping pong is doing, it opens a file and sets record lock is doing byte range locking on that file. So we open that file here, test that, it's used usually, and because we just now we use one cluster node more than we already have. We have 2 cluster nodes and we specify a number of 3 here. Let's have a look later what does it mean. So we do it and we see how many locks per second are possible. This is a fast machine, but I'm a little bit not so impressed about the numbers. What happens when we do the same here? ping pong test .3. Have a look here. Now the numbers of logs per second has dropped down about the half. If you stop it here again on this side, on the right side, you see it goes up again. And as far as we started on the other node, both nodes go down. It's expected because now there is some traffic going on. No data is written so far, but only the system calls have to be synchronized. And when we have a look here, what's going on the network, you see there is some traffic. It's not too much. If you look here on the first interface, it's only in the kilobyte range per second. Here it's a bit more. Yeah. When we stop one node, you also notice how traffic on the net is going differently. And if we stop it here, it should go down nearly to 0. As we can see, it said what was its expected. Yeah. Both interfaces have been defined in the corosync setup. So no traffic at all anymore. If I start it now in a different way, we want to also write some data and also read it again back. We started this way now, and we can see we get some similar numbers of logs per second and traffic on our. That's the node which is special between, it's not the public node interface, it's a special interface between the two nodes. And what happens with if we do it on the other node too? Look at the value we have so far, and now we started on the other node. An interesting thing is that we get a data increment of 2 now also on the other node, and what we also see, the logs per second have dropped dramatically, but that's exactly what we expect, and it's exactly, yeah, it's showing us it's possibly not the best performance we see here. When we stop it, so let's say on this side, the data increment, which you see here too, should go down to 1 again. So you can see it's true, and the log rate goes up. Same happens if we do it on the other side. When I kill the program here, it should go up there, and the data increment should decrease to 1 again. When I start it again here, it should go up again to 2, and the log per second decrease a lot. So that's some tests which should show that our file system setup seems to be working. So Michael Adam from CERNET in Göttingen said, well, you can also use another test just to show what's going on. Now we only define that we have 2 nodes, and the algorithm used inside ping pong reserves 2 places. When you do this test on a local file system, you can all use these ping pong tests on a local file system, and you should get the same results. We use it here to test 2 nodes on a cluster. When you use this on a local file system, you get something that bad lockup has been detected, and it's not shown here don't know whether other cluster file systems do the same way. When it goes here, as you see, something has been locked up completely, and we don't get that message that some lockup was avoided or something like that, with Michael talked about. I see it here when I use it on a local file system, but when we stop it here again, on this side, you see the locks go on again here. Yeah, so I would say also this test has passed. So we can thank, well, our OCFS2 configuration using corosync and pacemaker seems to be working so far. Yeah, but now we close this on both sides. It's an interesting, you should also try to use it. It's very interesting what's going on the interfaces you have chosen during cluster setup. Sorry, we now start CTDB. System control start CTDB service on this node. When we now look at the status of CTDB, you see it's currently disabled on this node and disconnected on the other node. That's normal because it must be enabled, and we can use CTDB enable to enable that node, and now we can have a look. It's okay. Now this local node seems to be running. Let's do it over here. Let's also start the CTDB service. And also let's enable it. When we want to see what's happening, let's start it also let's use CTDB IP, and let's start enable it here. It's disabled currently because we haven't enabled it on the other side, so we enable it here. You see it shortly goes to unhealthy, and after some seconds we see both nodes are working, they are healthy, and we see the public IPs on both nodes. These are the IPs we have configured. Let's look over here when we see what we have configured, and both configurations are the same on both nodes. Public addresses. We have chosen two nodes, two public addresses, and as you can see, this public addresses is currently running on node 0, and the other one is running on node 1. You can also see it when we look at here, IP address show, that this IP has been assigned. This is a public IP which clients use to connect to the cluster. So clients, when we look here, IP address show, we see, oh, it doesn't look so nice that it could. We have another, the other one running on this node here, 122 and 123. How does it look from the outside? Let's have a client here. Let's use smbclient -L, and let's have a look at the left node, the 122. Let's do it anonymously, and we see we get a result from that. We can also do it on the other node, 123, and we should get the same results. So we can connect to the cluster from using different IPs. Yeah, now let's really connect to that cluster using smbclient. We have used the share 01, and now I'm not able to connect anonymously anymore. Let's go this way. Alas, we are connected, and what we can see, we have the same data here as we can see on the cluster itself, on both. Yeah? We have the same data on all, and when I now remove the big CentOS thingy, it's the live ISO. It should have been gone on the other. Sure, here and here. One thing I should mention is this one. This special file which I have put here, and I thought about it, put it on a small different partition. It's a special log file used by CTDB. And if that feature isn't working with that log file, you can't use that cluster file system. You should probably name it different or put it in a more secret place, but it doesn't matter at all. So let us put some data. We put it back from the host system now, from a client, and let's look what's happening when we look at the I can't get rid of this pop-up stuff. What's happening, we put it now from the client side over, and as you can see, we have connected to the right one, so we should put it here, so we see these cluster nodes are connected now. In addition, you also see some traffic on the other node, but it's it's in the kilobyte range, so not very heavy traffic. It's synchronizing traffic, and but here we see it's about 60 megabyte per second. And it has finished. You can see, alas, we see the thingy is there. How far we've copied. So now it's connected to this cluster. But what happens if we disable this cluster? CTDB, disable this command should remove the public IP to which smbclient had connected. And if we do so, we notice that I can't put, it's frozen in some way. Alas, it doesn't work anymore. And yeah, we have removed the IP, but if we look here on the other node, IP address show, it has moved over to the other node. We see both the 122 and the 123 are now located on this node, but smbclient has timed out. It seems it can't switch over. That's client must be able, and Samba is using a very special IP tickle-ack mechanism to allow clients to switch over to the other node. We can use the kernel mount, but before, let us enable this one again. And CTDB IP, IP should tell us where the public IPs are. So the 122 is now on the left side on the node 0, and the 123 is on the right side. Let us now connect with the sys kernel module. So let's connect again to this one. It's the second, this one. Let's mount it to -O. Should not use abbreviation user, to use username. Mount, is it there or is it not there? Yes, it is there. We can remove that large ISO we have put there, CentOS, and as you can see, it's gone. It's gone. Let us copy over it again from the client, now using the sys module. Copy /mount, and as you can see, some traffic is going on. We used the right node and we see traffic over 100 megabyte per second, and that's also coming because the host system has a lot of 32 gigabyte of RAM, and the file is cached on the host, and it has been copied, and it's over there. So we do the same, which we formerly did with smbclient. We disable that node. And if we look here, let me mount, it has switched over automatically, yeah, which smbclient timed out, but this client and also Windows clients are able to switch over using these infamous tickle-ack IP mechanism, yeah. So this video was not meant to give you some details how to implement all the special configuration files and other stuff. It is more meant as a demo that you can get it working. Yeah. And finally, I mentioned it before that I did a separate install of a program called Linux Cluster Management Console. It's a Java GUI, and when you start it, you see what pieces are used to get the cluster working. And here, when you look at some parameters, for example, of the log manager used here, some special stuff must be thought about. The pacemaker, corosync, and all these resource agents are very, very complex beasts, and they might interfere with the working of CTDB. And when you look here, there's one thing. It's about split brain. Allow startup of this node without using stoned and fencing. Stoned is shoot the other node into the head. Fencing is make a fence between the nodes when some nodes gets wrong, runs havoc. I am not using it here in this demo, but there must be done something. The question is, who should take care of a split brain condition? And it's a question, yeah. Both CTDB and these two packages which were needed to get OCFS2 running at all might interfere with CTDB. Another thing you have to take into account is OCFS itself has possibly some internals which you need to take care about. Kernel panic and panic on oops must possibly be set. You have to look here. Possibly in another video I'll have a closer look at these ones, but possibly you have to set it. Yeah, and all this stuff might interfere how your overall system is working. It's not enough that your system is running. Also, you have to take care what happens if, let's say, one node is running havoc, and is it really going over all this stuff to the other node? And you know that you have to take some care for all this stuff. Possibly you have to add additional hardware, network cards or other stuff to get redundant connections between the clusters, and so a failover and a failback is possible. You should test that, yeah, with you see, this was the daemon to start. This is a resource agent. Also for the file system, the same holds true. What see, we use OCFS2, mount it to share 01. Yeah, when we have it over, when we look here over the clone, you see, overall with pacemaker I have stoned disabled at the moment. Otherwise, it would not start. Additional work needs to be done to get it working. The quorum policy must be ignored at all. On a two-node cluster, you can't get quorum. And with two nodes, and you see here, if we had enabled stoned action would be reboot at the moment. And there are other stuff you need to take care with, because you have to need to have a look, what are these resource agents doing, and do they interfere with the working of CTDB, because CTDB has its own mechanism to avoid split brain condition. But back to this. Why CTDB is running? Why isn't it seen here in this Java GUI? That's a problem. When we look here, there is a CTDB module available, a resource agent, but you can try it. It's a not very recent one, and I think it interferes a lot. You see what is needed. You need a shared file system and so on and so on. And you see a lot of stuff you need to configure when you pass it over here. You can graphically move it over. Yeah, you can add service to clusters and it appears here graphically, and then you can configure it. But I think in the current mode, it's not usable, and it would be a great thing to write or to modify the resource agent or write a completely new one. Better would be to interact directly with CTDB, maybe through scripts or other mechanisms, to get to get it working. At the moment, it's not possible to use it suddenly. But what's this all about, this GUI? It's not only GUI. You can completely set up your cluster with this GUI, and not only that, you can test it because resource agents used have a lot of more entry points as only start, stop, or restart, or status. You can also ask what would happen. Let's say we put this node into standby. If you stay here with the mouse, you see what would happen. Yeah, what could happen when you do it in standby. Now let's do it in standby. You see the control, the block manager has switched over to node 1, and also the file system has switched over. When I bring it online again, you see what would happen, and I warn you, it's not working correctly all the time, and this must be looked at. You see, it's not really, you get it into a condition when you switch it here around a lot. Even kernel panic is possible on your host system, and also because some parameters have not been set correctly till now, it may be that your virtual machines restart unconditionally when you play with these settings. But overall, this Java GUI is a very nice thing. Because of Java, you can run it on any workstation, and it connects via SSH, which you can see here at the bottom, and controls it over SSH, all the cluster nodes, and it's very powerful, and it's very further developed. And I've used let's have a look. Before, I've used it to set up a cluster, a 2-node cluster with DRBD, a famous RAID 1 similar over net setup for high availability. When one node dies, it's often used in primary and secondary mode. And as you can see here, this setup was done using 2 shares. On the bottom it was a DRBD share, and then the file system, it was usually X4 setup. And when both nodes are up, virtual IP address, it's the one which the client sees set up. When that one is up and running, The NFS server started, and also NMB and SMBD daemons are also started, and you can also use then this. It's only a picture. You can use it to test your setup. Yeah. See, we have some more services here, but this is only a picture. So I hope it gives you some information, and see you later, possibly when I do another video. Bye bye.